Sorry. It's better. I would like to thank the organizer for initiate this event again this year. And Jean-Luc sends his apologies for not being able to present today with us due to some minor health, but he's feeling better now. Today I will talk about the open science communities in the open sources ecosystems, but especially on the identifying the overcoming point of friction when the implementation of this joint project with the academic partners. So I'm Kevin Cortial, a PhD student CIFRE in OpenStudio and in the Clermont-Auvergne University with the Institut Pascal Laboratory. So quickly, OpenStudio is a digital services company since 2005 across multiple agencies in France. We have three axes of their works. The first is custom web development. So the second axis is the e-commerce with our Telia open sources CMS for the e-commerce. And the third axis is the artificial intelligence developed by our research teams. The research teams is launched since 2020. We have six people, sorry, in the department research at OpenStudio. We have launched 4 PhD since 2020, and they are Jean-Luc at the head of the department of research at OpenStudio, and we have also Jérémy Borot for the company lawyers, because we have many contracts with the academic partners. So it's very important to have this kind of profile for the department of research. So in the open science project in OpenStudio, we have 3 projects. The first project was the Atlas project. So the main goal of Atlas project is to create documentations and decision supports for the industry weaknesses from the COVID-19, for example, with the many shortage. And the follow-up project to the Atlas is now today the long-run project, as I work. The long-run project is to create simulation tools for accompany the industries into the transformations. For example, the industry can have many big transform with for the automotive industry, for example. There are many transformation with the hands of the combustive engine, for example. So long run promote a simulation tool to accompany the companies in these transformations. And the last open science project in OpenStudio is called Melia. The main goal to Melia is to create an open sources connected beehive. And for the research part of this project, the goal is to create nose detectors of the bee pheromone. So this is for the project of OpenStudio. And now I will talk about the open science definition, introductions, and it's with the complementarity with the open sources project. And then I will describe the feedbacks we have in OpenStudio with the 4 theses we have launched in Open Science project. So first, in fact, Open Science project have similar and natural synergies with the open sources principles. In fact, the main goal of open science is to diffuse and share freely the result of the research, the finding by the paper, for example, but they are also the data and, of course, the code and the software developed for finding the research result. So open sources, it's kind of like a branch of the open science. We can develop software, create code for the result, the scientific result. But they are also the open data, and with these 2 branches, we can successfully create the reproducibilities of the result. So it's a better way to create paper with code, of course. And there are another task for the open science. It's the open access of the scientific publications. Of course, there are many journals that's not openly the scientific publications. So the goal of the open access is to promote the journal that freely share the papers. So there are many complementary approaches between the open science and the open sources principle. In fact, there are many open sources platforms to help to initiate open science projects, and the goal is to share freely the findings and the results. And of course, this platform can help to share the data created by the research or used by the research for research finding. In fact, we use in OpenStudio many platforms with GitLab, for example, for create a community for work together on the code with the academic partners and internal in OpenStudio, for example. And this platform can help to improve the reproducibility of the scientific result with the paper with code, and also the transparency. It's very important for the scientific field to ensure the transparency of the result. So open sources, the principle is the same goals to the open science, for example, to create a community-driven development, create a peer reviews in a scientific field for publish in the journals. There are peer review mechanism with the senior researchers, and they are also the transparency task. And all these principles can ensure and promote the inclusivities and the accessibilities of the research. So by using many open sources technologies, we can create more custom solutions that not exist for the private solution, because in the research we can work on the tricky solutions. So the researcher can, with our communities, can create more custom solutions with, of course, open sources solutions. And all these relationships between the open science and open sources can promote and encourage the knowledge sharing for the scientific and create more collaborations between private academic partners, for example. So, as in open sources, there are many challenges and obstacles for the open science. In fact, we can work with multiple entities for the academic field. We can be a public university or private university. And there are many different tasks and different cultures about the open science and across the institutions. And this problem of cultural difference can be impact the standardizations of the open science. And of course, for private, for example, research issues, there can be problem of the intellectual properties, so the IP issues. And for the research, they can be create more relevant findings that want to create patenting, for example. So there are many problems for the IP issues. And there are many licenses if you want to use the open sources license. It can be conflict between these two tasks. So, as in open sources, there are problems for the sharing and the commercializations of the result of an open science project. In fact, they can be hard to consistent funding in the long term for maintaining the solutions for an open science project. And maybe with the company's finance research, the company want to need a return on the investment, for example. And with the actual limited budget for the public university or laboratory, of course, there are many laboratories want to add the values of this research. So many laboratories want to create patenting on their results for have royalties, for example. So there can be problems with an open science project. There are many balances solution between the IPs and the open science project. So the goal is to create hybrid models for create both the open science objective and the IP issues. And there are many aussi governments on the maintaining the open sources project during the time, for maintaining the code, the software, for examples, and for create other projects based on this result. And there are many also education gaps on open science for more education on the patenting or licenses. For me, I'm not an expert on the license and on patenting, but I try in my PhD to create an open source science project. So it can be other education gaps on these important informations. So the goal now is to you have feedbacks of the OpenStudio project in open science. So we have 4 current PhD theses. So we don't have a finished CIFRE PhD thesis. So I will talk about the first steps before the thesis, during the thesis, and finally I will take on the end of the PhD. But it's theoretically for us because we don't have a finished thesis. So the first steps, and very important step to work in an open science project, is to creating a collaborative contract with the academic partners. And this is the document that ensure the open science project and to determine the main goal, the IP, if is that, or who finance what. And this is the most important question in the collaboration contract, to determine who paid the salary, for example. And for our case, for example, our thesis with a hardware project, OpenStudio Digital Services, so we don't have laboratory space, for example. So there are costs for the academic partners. And if the academic partners want to create IP, for example, the percentage of the financing can impact the end of the thesis for the commercialization, for example. Publish in open access is often have more cost because the journals don't remunerate by the access with the publications. So the collaboration contract can determine who pay the publications on open access, the conference, the communication during all the open science projects, and also for the platform use for communicates on the open data, for example. So it's a balancing between the financing in the short terms and the long term for ensure the sustainability of the open science projects. And the goal is to create in the collaboration contract an equitable distributions between the fundings and the goals of the academic partners and the private. So the goal during the thesis is to manage the communications and the publication during the thesis. This is important steps because, for example, in my thesis, for defense my PhDs, I do to publish in a big journals because it's the rules of the doctorate school, but there are many differences between the academic expectations and the corporate expectations. So we want to manage this, and the rules can be right on the collaboration contract. So there are timely disseminations for the research findings, for example, and there are also different goals in the high quality of journals of the publications, because for the academic partners, more publish in the big journals is very important, and maybe for the other entities in the open science project, it's not the main goal, for example. So it's managed this in the collaboration contract also. So the goal is to create an equitable guideline between the publications and the main goals of the corporate and the academic partners. And in the collaboration contract, we can create a publication plan during all the open science projects to align both the corporate goals and the academic goals. So finally, for theoretical feedbacks, because we don't have CIFRE PhD thesis finish, the main goal, if they are create of patenting, for example, at the end of the PhD and the open science project, is to manage the intellectual property rights in this joint project. So if the research produced independently by one party is not very a problem, but the big problem is with the both parties. So it's very important during the open science project to have documentations of what each party have created for the open sources tool for that, for examples, like GitLab, for examples. And this information can be regular the updating IP agreements during the open science project. So this documentation in the collaboration contract is very important to manage this at the end of the PhD. They are important to have legacy experts for example, our company lawyer is very important to can have this experts in this project to manage this problem and to balancing the open science project and if they have the IP balancing. So that's it for my presentation. It's the last presentation of the session. So thank you very much for this beautiful event.
Thank you, Kevin.
Thank you.
Thank you very much.